Example, consider the series 1 divided by 1 into 2 plus 1 divided by 2 into 3 plus 1 divided by 3 into 4 plus and so on plus 1 divided by n into n minus 1 plus and so on. Here un is equal to, we know that resolving a partial fraction, un is equal to 1 divided by n into n minus 1. u1 is equal to 1 divided by 1 into 2 is equal to 1 minus 1 by 2. u2 is equal to 1 by 2 minus 1 by 3. u3 is equal to 1 by 3 minus 1 by 4. By resolving it as by resolving it as wait by resolving partial fraction, this is proper fraction. By resolving it, we get 1 minus 1 by 2. u2 is 1 by 2 minus 1 by 3. u3 1 by 3 minus 1 by 4 and so on. un is equal to 1 by n minus 1 by n plus 1. Sum of partial sum. A sequence of partial sum is Sn is equal to u1 plus u2 plus u3 and so on u of n. Adding all these terms, u1, u2, u3 and so on u n. 1 by 2 minus 1 by 2 and plus 1 by 2 minus 1 by 3 plus 1 by 3 get cancelled and so on. This term and this term get cancelled. Sn is equal to 1 minus 1 divided by n plus 1. If we apply limit n tends to infinity, Sn is equal to limit n tends to infinity 1 minus 1 by n plus 1. This tends to 0. We get Sn is equal to 1. This is finite quantity. Therefore, the sequence of partial sum converges to 1. This implies series summation un is convergent. Next, second example. Consider the series 1 cube plus 2 cube plus 3 cube plus and so on n cube. We know that summation n cube is equal to n into n plus 1 divided by 2 whole square, or n square into n plus 1 divided by 4. Sequence of partial sum, limit n tends to infinity, Sn is equal to limit n tends to infinity n square into n plus 1 divided by n square into n plus 1 whole square divided by 4. Tends to infinity as n tends to infinity. This implies series un is divergent. Sequence of partial sum diverges to infinity. This implies series u of n is divergent. And example 3, consider the series 1 minus 1 by 2 plus 1 by 4 plus and so on minus 1 by 2 whole raised to n minus 1 plus and so on. Solution. Here un is equal to minus 1 by 2 whole raised to n minus 1. Un is equal to minus 1 by 2 whole raised to n minus 1. Sequence of partial sum. Sn is equal to 1 minus 1 by 2 plus 1 by 3 minus 1 by 4 plus 1 and so on minus 1 by 2 whole raised to n minus 1. We know that geometric series sum of geometric series is Sn is equal to 1 a into 1 minus r raised to n divided by 1 minus r when r less than 1. Here r is equal to 1 by 2, therefore this is less than 1. This is less than 1. If we simplify, get 2 by 3. 2 by 3 2 by 3 2 by 3 is a finite quantity. Therefore sequence of partial sum is finite, series is convergent. Okay, thank you.